One of the earlier scientific possibilities that supposes that the light got here by natural means was that the hypothesis of what they now call sea decay. And this is the idea that the speed of light may have been much greater in the past. And this is a really interesting idea. You see, the idea is that we're questioning the velocity in that little equation, the v. The speed of light might have been much, much greater, in which case it could have traversed an enormous distance in a relatively short amount of time, only today slowing down to its present rate. You see, the distant starlight argument assumes that that light speed has always been constant, but perhaps it hasn't been. And one misconception I want to clear up, a lot of people think, well, doesn't that violate Einstein's relativity? Because a lot of people have heard it said that relativity teaches that light is constant, the speed of light is constant. And that's true, but it doesn't mean what you think it means. When they say the speed of light is constant in relativity, they mean that if two people measure the same beam of light, they'll get the same answer, even if they're moving relative to each other. They'll get the same velocity for that light. It doesn't mean that the velocity of light has always been constant in time. Relativity doesn't say one way or the other, whether light is constant in time. So this would not violate relativity. It might be problematic in some other areas of science, but it doesn't violate relativity. And so that's the proposal. The speed of light may have been much greater than it is today. But there are some potential problems with this model. And this is why a lot of creationists have abandoned this idea and think that maybe the answer lies elsewhere. You see, the speed of light is not arbitrary. It is linked to nature. There are a lot of things that depend on the speed of light being just so. And let me give you one example. Another famous equation, E equals mc squared, Einstein's famous formula. And that equation relates energy and mass. E is the energy of something, and m is the mass that something possesses. And those two quantities are related by the speed of light, which is the c in that equation, the speed of light squared, in fact, which is quite large, because if the speed of light is large, the speed of light squared is very, very large. So what that means is that if something has just a little bit of mass to it, it has an enormous amount of energy. Now that's all fine and good, but what happens if we change the speed of light? Well, logically, if light has decreased, if the speed of light has decreased, then that means either energy has to go down or mass has to go up. One of those two things has to happen. And so you might imagine Earth orbiting the sun. It orbits because it's got orbital energy. Well, if the speed of light drops, you might say, well, the energy drops, and so the Earth would plummet into the sun, potentially. And that's not good. Or the other possibility is, well, maybe the mass goes up to compensate for that changing speed of light. And that would work too, but if the Earth and the sun both become more massive, their gravity increases, and the Earth falls into the sun again, you see. So you get sort of the same answer. There's some possible ways around this, though. I mean, perhaps other constants also change to compensate for that. Maybe the gravitational constant decreases, for example, and that would allow the Earth to continue to orbit nicely. So this isn't necessarily a fatal argument, but it is something that we have to take very, very seriously. And there are other possible solutions, too. I've heard a number of very intelligent creation scientists who hold to this idea, who think that it is possible for a CDK to actually solve the distant starlight problem. A third point is this testable? What would we expect to see in the universe if, in fact, light has decayed? I'll tell you that I've looked at a lot of images of the universe. There's nothing that shouts out to me that the speed of light has decreased in time. I don't think there's anything that screams out that requires that the speed of light has decreased. It may have, but I don't think we see compelling evidence for that today. Nonetheless, again, there are intelligent creation scientists who hold to this idea, and so my conclusion would be that this is indeed a potential solution to distant starlight, but there are a lot of details that have to be worked out before I would want to jump on this particular model.